slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast, I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you...
Good morning, everyone, and thank you for being here while we share with you our exciting new results about our galaxy, the Milky Way. Our home in this universe, what fills our night sky on a dark summer night. At its heart, towards the constellation Sagittarius, is Sagittarius A star, the supermassive black hole suspected to reside there. A source that has been a focus of intense astronomical studies for decades. Observations of stars orbiting around it revealed the presence of an object that is very massive, 4 million times the mass of our sun, but also very faint. For me personally, I met it 20 years ago and have loved it and tried to understand it since. But until now, we didn't have the direct picture confirming that Sag A star was indeed a black hole. Today, the Event Horizon Telescope is delighted to share with you the first direct image of the gentle giant in the center of our galaxy, Sagittarius A star. This image shows a bright ring surrounding the darkness, the telltale sign of the shadow of the black hole. Light escaping from the hot gas swirling around the black hole appears to us as the bright ring. Light that is too close to the black hole, close enough to be swallowed by it, eventually crosses its horizon and leaves behind just a dark void in the center. Getting to this image wasn't an easy journey. It was one of building a worldwide telescope array and a global collaboration. One of getting and processing petabytes of data collected from those telescopes. Of imaging algorithms more complex than many that have ever been developed. What made it extra challenging was the dynamic environment of Sag A star, a source that burbled and gurgled as we looked at it. And the challenges of looking not only... something is advancing the slides without... Can you please go back to the earlier slides? Let's see if this will work. What made it extra challenging was the dynamic environment of Sag A star, a source that burbled and gurgled as we looked at it. And the challenges of looking not only through our own atmosphere, but also through the gas clouds in the disk of our galaxy towards the center. It took several years to refine our image and confirm what we had, but we prevailed. The HD collaboration has indeed been hard at work imaging black holes with exquisite resolution using new techniques. In 2019, we revealed the very first such image, that of the supermassive black hole in the M87 galaxy. That black hole is 1,500 times more massive, making its horizon 1,500 times larger. But it is also 2,000 times further away from us. This makes the two images appear very similar to us when we gaze at them in the sky. But the two black holes couldn't have been different from each other in practically every other way. The one in M87 is accumulating matter at a significantly faster rate than Sagittarius star. But perhaps more importantly, the one in M87 launches a powerful jet that extends as far as the edge of that galaxy. Our black hole does not. And yet, when we look at the heart of each black hole, we find a bright ring surrounding the black hole shadow. It seems that black holes like donuts. I wish I could tell you that second time is as good as the first when imaging black holes, but that wouldn't be true. It is actually better. Now we know that it wasn't a coincidence. It wasn't some aspect of the environment that happened to look like the ring that we expected to see. We now know that in both cases, what we see is the heart of the black hole, the point of no return. These two images look similar because they are the consequence of fundamental forces of gravity. Space-time, the fabric of the universe, warps around black holes in exactly the same way, regardless of their mass or what surrounds them. This is what we had hoped to find, given the predictions of Einstein's theory of general relativity. And it is exactly because of this fact that we are able to use these new observations, the image of Sagittarius star, to perform one of the strongest tests of general relativity to date. What was remarkably helpful to us when performing this test was the amount of information we already had about Sagittarius star before our observations. The astronomy community has monitored for decades the motion of stars around the dark center of the galaxy. By tracing these orbits, we have come to know the mass of the black hole with extreme precision. That allowed us to make a prediction for how big the image and the black hole shadow should be, if Einstein's theory is right, with no wiggle room and no parameters to adjust. The only way to change the size of the shadow is if we change the theory. And what we found was that our image was in very close agreement with theoretical predictions. These observations leave us very little freedom to change Einstein's theory of gravity. Now we have two laboratories in the sky, M87 and Sagittarius star, for exquisite tests of extreme environments. We learned so far that we understand gravity pretty well. But as you will hear later, as sophisticated as our simulations are, we discovered that we still have a ways to go with modeling their turbulent environments.